Ladies and gentlemen, so today we're going to talk about lesson 4.3, which is writing equations in point-slope form. We've talked a little bit about standard form, that's the ax plus by equals c, and we've talked a lot about slope-intercept form, which is that y equals mx plus b. Well, today we're going to throw in one more form of a linear equation. So when we're writing equations in point-slope form, we're working on the skills of using function notation, evaluating functions, and interpreting statements in function notation. And we're going to construct linear, still no exponential functions, including when we're given sequences, graphs, descriptions, or input-output pairs. So for this one here, our first and only vocab term is that idea of point-slope form. So point-slope form is an equation of the form y minus y1 equals m times x minus x1, where m is the slope and x1, y1 is a given point on a non-vertical line. When we have a vertical line, we talked about this before, a vertical lines, the equation looks like x equals a number, so it's a different form and it's not a function. We're talking about point-slope form, again, we're talking about those slanted lines, diagonal lines, or horizontal. So let's practice with this skill here. We're going to write the equation of the line in point-slope form. So I'm given the slope and a point, just like I was given key information when I was talking, I think it was lesson 4.2. But this time I want to write it in point-slope form. What we're going to practice with today is we're going to deal with the three different forms of equations. So point-slope form tells me that I'm looking for y minus y1 equals m times x minus x1. If I see this here, I see my x and y values, x1, y1, and I see my slope, which tells me m. So all I have to do is plug it into the equation. I'll have y minus my y1 value equals m, I have an m value, equals my slope of negative 1/2 times x minus my x1 value. And at this point, I'm done. I have my equation in point-slope form. All I had to do was plug in the pieces. Well, now sometimes it's more useful to have an equation in one form of the other. So what we're going to do is we're going to practice turning our equations into different forms. So this one here was one of our homework problems. It's page 235, number 3. Our next two practice problems will also be from the homework. So if you're taking notes today, you're going to have a good start going on your homework. So now let's try one more problem from the homework. This time we're going to make it a little more complicated. We're starting with our equation and it's in point-slope form, but I want to turn it into standard form. Well, standard form is that idea of ax plus by equals c, where a and b are integer values. So when I look at this here, there's really two different ways to solve the problem. I'm going to show you the way that I would solve it first, and then I'll show you the textbook way. They're basically the same thing. They just follow a slightly different order of steps as we're going through it. So when I first see this here, well, let's back up for a second. Let's first think if we can pull out the pieces. If we're talking about slope-intercept form, point-slope form, I can pull out my point and my slope. If I'm looking at this here, I see that my slope is that m value of negative 3/2, and the point, the ordered pair that I'm given, well, when I'm thinking about point-slope form, I have y minus y1 equals m times x minus x1. So my x value in my point is really a negative 1. X minus a negative 1 gives me positive 1. And my y value is going to be a negative 7. Same idea. Y minus negative 7 is y plus 7. So that was just a little side note on how to deal with the different ideas for point slope. But now let's go back. We're thinking about standard form now. Well, the way that I would solve it, I'll show in purple. When I look at this here, I know that standard form doesn't have any parentheses in it. So the first thing I want to do is I want to get rid of those parentheses. I'm going to distribute across to get rid of it. And so I'm left with y plus 7 is negative 3/2 x plus a negative 3/2. Well, what I'm going to do is I'm going to change that minus 3/2 and I'm just going to turn it into a negative 1/2. Those two ideas are equivalent, so I didn't change anything mathematically. I'm just changing the way that I've written it because I'm going to get y all by itself as my next step, and I'm going to take away 7 from both sides, which leaves me with y equals negative 3/2x minus 8.5, or plus a negative 8.5. What I've done here is I've really turned it into slope-intercept form. I can see y equals mx plus b. But this equation asks me to go all the way into standard form. So what I'm going to do, standard form shows me that I need to have the x and y on the same side. So I'm going to add 3/2 x to both sides. And when I do that, I get 3/2 x plus y equals negative 8.5. Well, I'm close here. I see that idea of ax plus by equals c, but my a and b values are not integers. An integer is a counting number, a whole number. It can be positive or negative, but this 3/2 or 1.5 is not an integer value. So what I'm going to do to turn that into an integer, I'm just going to multiply everything by 2. As long as I multiply the whole side of the equation, if I multiply both sides of the equation, then I've kept my solution set. I haven't changed anything about the problem. So if I multiply 3/2 x by 2, I'm left with a 3x. If I multiply 2 times y, I'm left with 2y. And negative 8.5 times 2 is a negative 17. My final answer is 3x plus 2y equals a negative 17. Beautiful, I got there. Now the way the book shows you is slightly different, and I'll show it in green here. The book thinks that you should first get rid of that over 2 part. But we want to get rid of the fractions first, and that works. If that works better for you, we can do it that way. I'll rewrite the equation. I have y plus 7 equals negative 3/2 x plus 1. And to get rid of my fraction here, I'm going to multiply by 2. Before I do anything else, I'm going to multiply both sides of the equation by 2. That leaves me with 2y plus 14 equals negative 3 times x plus 1. Now I have all integer values. Next step that I need to do is I need to get rid of my parentheses. So I'm going to distribute, and I get 2y plus 14 equals a negative 3x plus a negative 3. Well, now I want to move my x over to the other side. I'm going to add 3x to both sides. And I get 3x plus 2y plus 14 equals a negative 3. Last step is to take away 14 from both sides. And I'm left with that same answer. 3x plus 2y equals negative 17. Same answer, slightly different steps to get there. Both ways are mathematically legal, and it's up to you which way you find most comfortable. I like doing it this way because half the time it'll ask you for slope-intercept, which is this version right here, and sometimes it asks you for standard form. But you can do it this way, up to you. Let's keep going, and we'll try another one out of the homework. So for this one here, again, I'm given point-slope form, but this time I want to turn it into slope-intercept form. Slope-intercept form is the form that you guys are probably most familiar with at this point, which is y equals mx plus b. So what we want to do is we want to get y all by itself on one side, we want x with a coefficient, and then the constant left, that start value left on the other side. Just like when I was turning it into standard form, the first step I need to do is I need to get rid of those parentheses. So I'm going to distribute across, and I get y plus 3 equals, well, negative 1/3 times 2 is going to be a negative 2/3 x plus a negative 1/3 of 6 is a negative 2. I only have one step left to get to get y all by itself, and that's to get rid of this 3 here. To get rid of a positive 3, I take away 3 from both sides, and I get y equals a negative 2/3 x plus a negative 5, or minus 5. All I had to do was get all my pieces in the correct spots, and I've changed forms. So now your homework. Page 235, 3 through 36, multiples of 3, and then 40 through 42 and 48. Now, what I'm going to tell you right now is that on this homework assignment, the graphs are not worth any points. I think there's a few problems where it asks you to turn it into one form or the other and then graph it. I think that's a great thing to practice, and I think it's useful for you to practice that skill in your notebooks, but because it's difficult for you guys to self-grade graphs, I'm not applying any points. So if you are confident with your graphing skills, you can skip those problems. Otherwise, you can practice sketching the graphs in your notes. I will include the graphs in the answer key, but they're not going to be worth any points. Go ahead and get started on this task. Thanks, guys.